kick off the interviews with Devin Peterson from Ponder. Ponder is taking Modin, a distributed compute library for Python, and pushing data science compute directly into the database. Welcome to Talk Python here on Startup Row.
Thank you.
Yeah, it's fantastic to have you here. You know, we met yesterday here at PyCon US, and you were telling me about your project Ponder and how it's built upon Modin, the open source project. And as I looked around, I'm like, everyone here has a story. And I just thought it'd be so great to have you on the show along with all the others and just kind of tell your story. You know, how did you get here to Startup Row at PyCon?
Yeah, it's interesting. So Modin started as my PhD project, and I was doing my PhD at Berkeley, and I started in the genomics world, trying to build large-scale data science tools for the people who actually do the science. I'm not a biologist myself. I don't know the first thing about biology, honestly. But
you got some good programming skills, and they can always use that applied to their data, right?
Right.
Yeah.
The problem was we were building tools in Spark, and it was really hard for these Spark-like APIs to translate natively to the way that they were reasoning about data, and they were using Python. And so there's a very kind of natural way that scientists think about, interacting with data that's not Spark, right? It's not intuitive as intuitive in Spark, even PySpark, right? So
a lot of Python people avoid databases as much as they can, at least SQL and directly talking to them like that.
Yeah, totally. Because often the way, when you're exploring data, you have a mental model of how you want to interact with the data. And that is not SQL often. It's just the way that it is. So I had a moment there where a data scientist was like, if I don't want your tool, can you just make my tool run faster? And so I was like, yes, wait a second, this is actually a real project. And so I started looking into pandas and looking into the world of databases and the kind of academic space. And nobody had really dug that deep into pandas, because in the academic sense, everybody was like, okay, pandas is just a bad database. That's what database people thought at the time. So we did a bunch of work, and it kind of turned out that's not the case. They're totally new things. And so from there we built Modin, and now with Ponder we're kind of extending that to basically bridge these two worlds where you can use Python, but we're generating SQL on the back end and able to run pandas directly in your database or your data warehouse.
Yeah, fantastic. So when I first heard about what you're doing at Ponder, I immediately thought of Dask. And Dask is another popular startup open source startup success story with Matthew Rocklin and Foreman Coiled and stuff. And I mean, I think they may have outgrown Startup Row, but good for them.
Yeah, totally.
But my first thought was, okay, well, how is this different than Dask? But the big difference is Dask is grid computing and yours runs in the database.
Yeah, for Ponder, definitely. Open source Modin also integrates with Dask clusters as well. So Dask has Dask data frame, and that runs on Dask clusters. We can also run a Modin open source on Dask clusters. It's very important to us that whatever infrastructure that you have, you can run pandas on top of that. So Ponder is the next level of that, where if your data is in the database, it doesn't leave, right? We can just execute it directly there, and all of your assumptions from Python and pandas hold true in the database, even though the database actually doesn't like the assumptions that you might have in pandas, right? We emulate those behaviors, and we've done a lot of work to actually make that feel very native. So that is a key difference with Ponder and Dask, though, is that your data never leaves the database. So you don't have to have a separate Dask cluster to kind of pull the data into and execute on it there. You can just run things natively in the database or the data warehouse.
So if you have a large database, you already have a probably powerful database server. Why transfer all the data off of that, load it into something else, analyze it, and then throw it away, right? Just make it run there.
Exactly.
Yeah. So maybe a quick elevator pitch type of thing might be like, you all take pandas and turn it into SQL statements that run on the database, but people get a program in pandas.
Yes, exactly.
Is that more or less it?
That's exactly it, yes. Some things that are really, really native in pandas, you like describe, for example, df.describe. Super, super common.
It seems easy. It just gives me some summary stats, right?
Yes, exactly. That's 300 lines of SQL. No. You wouldn't believe it looking at it, though, because it seems so simple, and it is a simple output, right? I want to get some summary statistics from my data. But SQL is so declarative, and the language itself doesn't lend itself well to this type of iterative, interactive kind of like workflow. So,
right. And the notebooks remember step by step. They have like a history, sort of a memory, whereas SQL's every statement is standalone.
Exactly. Yeah. So all or nothing, basically. And you have to do the whole thing up front. And that's the thing people love about Pandas, is that you can incrementally build these things up. So we're giving that interface to SQL, basically.
Awesome. All right, well, let's wrap this up with a bit of a talk. How you got to Startup Row? How did you start this company?
Yeah.
Where are you? Like, so many people are excited to take their open source work and instead of making it their side job or something they do part time at their company, make it their full time energy. And you're there. How'd you do it?
Yeah. So the way that we started was we talked to a lot of companies where they basically asked us, can you make this work on top of our infrastructure? We didn't support, we only supported in the open source Ray and Dask. And we saw a motion there to have kind of an open core model. So we follow the open core model where these more enterprisey features like, security features and being able to push into data warehouses, right? Like an individual, consultant may not have, a data warehouse. They probably don't, right? But enterprises do. And these are the types of features that enterprises really care about. So this open core model, I think, lended itself really well to our business, particularly because, enterprises will pay for these features. And so, and then we went out and we raised a seed round and, saw the opportunity to come here and be in PyCon Startup Row. Unfortunately, it's a competitive process. Really, it is.
Yeah.
We feel very fortunate to be, chosen among the few that are chosen here. But yeah, that's kind of our journey is basically, starting talking like. So for folks out there who are like interested in this, talk to people who are using this, people who are interested in the problem that you're solving, and figure out where the gaps are and kind of ask questions. Don't be afraid to ask, like, would you pay for this? Or how much would you pay for this?
Yeah.
Those questions, they're uncomfortable to ask. And like,
especially as a developer who's not used to presenting salesy type marketing things. You always, salespeople, that's kind of yuck. It's a necessary evil.
Totally. It totally is. Yeah. So, but you have to ask, because how do you know if you can kind of take that next step unless you ask, hey, would you pay $50 a month for this? Would you pay $10 a month for this, right? You can't know unless you really go out there and ask. So that's what I would encourage folks to do if they're interested in this is, find those gaps and really ask the hard questions that are kind of hard, but yeah.
Awesome. Well, congratulations. Thanks for taking the time to talk to us.
Thank you.
Yeah, you bet. Bye. Next up is Generally Intelligent and Josh Albrecht. Generally Intelligent is an independent research company developing AI agents with general intelligence that can be safely deployed in the real world. Josh, welcome to Talk Python to me.
Hey, thanks.
Hey, it's great to have you here. Tell people quickly who you are.
Yeah, so I'm Josh Albrecht. I'm the CTO of Generally Intelligent. We're an AI research company based in San Francisco.
Awesome. I love the humbleness, generally intelligent, right? Not a super genius, but it's a clever name. I like it.
Thank you.
Yeah. And what's the problem you're solving here?
So yeah, we, kind of, as it says on the tin, like we're working on artificial general intelligence. We don't usually like to use that term because it can mean lots of different things to lots of different people. But in general, what we're working on is making more capable, safer, more robust AI systems. And in particular, we're focused on agents, so systems that can act on their own. And like right now, mostly what we're focused on is agents that can work kind of in your browser, on your desktop, in your code editor, those kind of virtual environments and digital environments.
How much of this are you envisioning running locally versus running on a big cluster in the cloud?
Yeah, I think it'd be nice someday in the future to have things run totally locally, but right now, a lot of these technologies do require a large cluster of GPUs, which are very expensive, and most people don't even have a GPU or have a bunch of GPUs at home, so it's kind of hard to actually get it running locally. Hopefully someday in the future we'll be able to do that, but for now you'll probably need internet access to use a lot of these things.
Right. Okay. So you're envisioning a bunch of these agents that have access to an API that can quickly respond.
Right.
Over there.
Yeah.
Okay. So give us some ideas,
Yeah, so what this looks like concretely, you can imagine like a coding agent. So one thing you can do with GitHub Copilot right now is you can write a function declaration in a doc string and have it generate the function. But you can imagine for a coding agent, not only generate the function, but also generate some tests, run those tests, see errors in those tests, try and fix the errors, kind of do that whole life cycle to ideally give you a output that's actually a lot better. And then also, if you're thinking about this as an agent, maybe it's more of a back and forth. It's not just an autocomplete in your editor, but it can come back to you and say, I'm sort of uncertain about this part here. What did you mean? Or, I wrote these tests, but I'm not sure if it's quite what you wanted. Or maybe, it's kind of running in the background and flagging different things that it sees in your code base. Like maybe you made some change and it can detect that your doc string is out of date and kind of flag that for you. So thinking about it more as an actual pair programmer.
Okay. Is it primarily focused on... Yeah. Are you thinking to focus mostly on programming, or is it more broad, like, I'm looking for a great deal on this classic car. Go scour the internet and negotiate it for me.
Yeah. So the company is generally intelligent, so we certainly do want to be able to address all these different use cases over time. I think for us right now, one of the domains that we are interested in is code, especially because it's so objective. You can know if it's right or wrong. You have tests, that sort of stuff. So it's a nice playground for ourselves. And it's something that we can build for ourselves to kind of iterate on internally. Mm-hmm. But we're not exactly sure what the final product will be. We're also training our own kind of large language models. We might prototype some stuff around those. So there's lots of possibilities. We're not wedded to anything yet. Thankfully, we have the luxury to kind of take a little bit of time to figure that out as a research company.
Yeah, that's excellent. What about science?
Yeah, science is definitely a thing that we're interested in. It's pretty hard. And so, do we necessarily want these things running around making things in test tubes or whatever? I think that's probably a little bit harder than coding, and coding's already pretty hard. So I think we'll get there. That's some of the stuff that we, personally on the team, are really excited about. To see, how can we use these to uncover new cures for diseases or whatever. I'm really excited for that kind of stuff a little further in the future.
Yeah, that'd be amazing. I was just talking to someone on the expo floor hall here about protein folding.
Yeah.
Right, that kind of stuff.
Yeah.
It's kind of been elusive for people. We more or less have just tried to brute force it.
Yeah.
Right, with the folding at home thing. Let's just run every computer and just try every possibility. But there's a lot of possibilities.
Yeah, exactly.
All right, so where's Python fit in here? What are some of the tools that you're using?
Yeah, so Python is... We love Python. We basically write everything in Python or Bash, but mostly Python. Or Python generates a little bit of Bash, but it's mostly Python. So we use a lot of PyTorch for our models. And then other than that, let's see, what other libraries do we use? I mean, we use tons of Python libraries like NumPy and scikit and adders, and just there's so many wonderful things that people have built that we just that are just so nice to work with. So we love that Python, you can kind of take it, open it up, look at all the source, and really understand everything in that full stack. For us doing research, that's really valuable to be able to know everything that's going on.
Yeah, you have these Lego block types of things. What if we arranged it like this? You don't have to write the whole machine learning bit. You can click a few pieces together and off it goes.
Yeah, we build on top of Mosaic, for example, or other open source libraries that people put together for training stuff and kind of adapt it for yourself. It's so nice that you can just pull things in and so easily change everything.
Yeah, awesome. I must have somehow blinked along the way, and these large language models just seem to have come out of nowhere, and all of a sudden, AI is one of these things. It's kind of worked, kind of recommended stuff, and now all of a sudden it's mind-bogglingly good.
Yeah.
Do things like TensorFlow and stuff work with these large language models, or do you need other libraries?
Yeah, so TensorFlow and PyTorch are probably the two main machine learning libraries that people do deep learning systems on top of. Pretty sure that GPT-3 and GPT-4 were probably trained on top of PyTorch. I think a lot of the stuff at Google, like Palm and Bard and those types of things, are trained on TensorFlow. But at the end of the day, they're actually very similar, and they're sort of converging to kind of similar ideas too as well. So it's interesting to see them evolve.
Yeah, fantastic. All right, last question, close out our conversation here is, we're sitting here on Startup Row, well, just outside of Startup Row, I suppose, but it's, there's a bunch of people out here who are working on open source projects who would like to somehow find a way to make it their passion, their job, spend more time on it, maybe make it a company. How'd you get here? Tell people your journey. Yeah, so we got here in a little bit of a different route. So a lot of us were working at a previous company called Sorceress that did more of an applied machine learning thing, where we were taking machine learning and applying it to the job of recruiting and trying to figure out, can we find good people online that might be a good fit for a particular position, and and reach out to them and get them interested in the job and that sort of stuff. We went through YC with this in 2017, and we raised our Series A. But eventually, it was growing. We had a few million in revenue and customers and everything. And it just, in 2019, we were looking, and it felt like, there's so much really interesting stuff happening in self-supervised learning and in deep learning and in machine learning. And it feels like,
recruiting is very important, but is this going to be the most important thing in the world? Is this going to really be the thing that changes the world?
Yeah.
Or will there be something a little bit larger in this more general purpose AI? And the more we thought about it, the more we felt like, the AI stuff is probably going to have a huge impact. Like, we should really be working on that. So we kind of wound down the previous company. A bunch of us moved over and started up Generally Intelligent. And then we've been working on stuff ever since then.
Fantastic. Well, I know you've got some really cool stuff where the agents can sort of look at the code they're writing, think about it, evolve, and it looks like a really interesting take. So congratulations, and I'll put the link to all your work in the show notes. People can check it out.
Yeah, sounds good.
Yeah.
Thank you very much.
Yeah, thanks for being here.
It's great to chat. Take care.
You bet. Now we talk with Mo Sarat from Werobots. They're building the database platform for geospatial analytics and AI. Hey Mo, welcome to Talk Python.
Thank you so much.
Yeah, it's great to have you here. Let's start off with a quick introduction. Who are you?
Absolutely. So my name is Mo, and I'm the co-founder and CEO of a company called Werobots. Werobots' grand vision is enable every organization to drive value from data via space and time.
Awesome. I love it. So, thanks for being here on the show. Let's dive into Werobots. What is the problem you're solving? What are you guys building?
Think about, again, every single data record that is collecting on a daily basis. Even we're here right now, we're talking on this podcast at this specific location at this specific time. So if you think about the space and time aspect, it's actually a very important aspect of every single piece of data that is being collected.
Right. If we're here next week, who knows why we're here? We could be here for a different reason. That might mean something different, right?
Absolutely, yeah.
Okay.
So that's exactly. So that space and time lens that you can apply to your data can actually also tell you a better story about your data. You can drive more value, more insights from your data if you apply that space and time lens. And this is basically what we are, not necessarily this is exactly what we focus on in our company. But more specifically, we are trying to build kind of a database infrastructure to enable people to use that space and time lens to drive value from their data.
Okay, fantastic. Now, when you talk about space and time and data, are we talking records in a time series database? Are we talking regular database or NoSQL? Or could it be even things like the log file from Engine X about the visitors to my website? What's the scope?
The scope is actually very wide. So think about any data could be structured, semi-structured, unstructured data that you have. And as long as it have kind of a geospatial aspect to it, and geospatial aspect to here, it means if the record or the document was, let's say, created in a specific location or represent an event that happened in a certain location at a certain time, or represent an object or an asset that you monitor at different locations at different times. Whatever it is, it can be stored in any of these kind of formats as long as it have this kind of geospatial aspect to it. You can definitely apply that kind of geospatial or space-time lens to it.
Right. Okay. So what are some of the questions you might answer with
questions? It varies. So it depends on the type of the data, it depends on the use case. You have a horizontal technology that enable so many industry verticals, but I'll give a couple of examples.
Yeah. Make it concrete for us.
Absolutely. Think about a logistics company or a delivery company, the most well-known delivery company is Amazon, right? You go to the app, you purchase an item or a product, and then the whole journey of that product from the supplier to the warehouse to the driver, the Amazon driver, all the way that makes it to your door, there's a whole kind of everything has a geospatial location to it, attached to it. Mm-hmm. The package is moving around. You're located somewhere. Their house is at a certain location. Handling the logistics behind all of that, understanding how things are, you're monitoring all these assets in space and time as it reaches the door. This whole journey, there's a lot of kind of data processing, data analytics happening that you have to do through, again, the geospatial kind of aspect, the geospatial contextual aspect of things. So this is one example. Another example could be if you're an insurance company and you're insuring homes, for example, and you want to understand what are the nearby kind of climate conditions, natural disaster conditions compared to your home. There's also the home has a location, these kind of natural disaster weather changes at different locations all the time. That will impact how you take decisions about insuring these homes.
Right. Do I buy it
Do we
do
buy it or
insurers
no?
want to insure it? What do I have to pay
Exactly.
to do that? Okay.
So that's another example, again, that the space and time lens or the geospatial aspect impacts your decision when it comes to taking. It's an important decision that you take in here. So that's another example. So these are just a couple use cases, but there are tons of other use cases and use cases that may not exist even yet. So there's a lot of movement now into climate tech and ag tech. And we are, like, what we're trying to do at Whereabouts is that we're building the database infrastructure that enable the next generation climate tech and agriculture technology.
So they can ask the questions that they might have, but you already have the machinery to answer them.
We have machinery to answer them, and they build their own secret sauce on top of our infrastructure. Yeah.
So it's kind of a framework platform.
Absolutely. Yeah.
Got it.
Yeah.
So Python, where's Python fit in this story?
That's a great question. So geospatial data, or the geospatial aspect of data, has existed for so long. As you said, we live in the space-time continuum. Everything has a space-time aspect, geospatial aspect. But and that's why developers already have APIs to interact with geospatial data. And these APIs, the language varies. So there are some people that use SQL, like to interact with the data, process the data in either SQL databases or any other kind of SQL processing engine, right? But a lot of the geospatial developers or people developing with geospatial data, they use Python. There are so many libraries that use Python to actually. Example of these libraries is a library called GeoPandas. It's a fantastic library. It's an extension to Pandas to kind of wrangle and crunch geospatial data.
Ask questions about what things are contained in here, what things are outside of here, how far away is it?
Absolutely. Okay. So this is what GeoPandas does. The only problem is that GeoPandas is a library, has a great functionality, but again, is not enterprise ready for the most part. It doesn't scale, all that kind of stuff. So what we do at Whereabouts is that we provide SQL API to the user to run spatial queries on the data, but we also provide a spatial Python API. Like if you're using GeoPandas, you can use the same API, do the heavy lifting, enterprise scale kind of processing of the data using our platform, and then do the major GeoPandas kind of functionality you're familiar with to, again, do the geospatial processing with it. So this is how it fits within Python. And actually, looking at we have an open source software called Apache Sedona. It's an Apache under the Apache license. And it has all these APIs, SQL and Python. And Python is the most popular. So It's been, the Python package alone on PyPy is being downloaded 1 million times over on a monthly basis as we're speaking today. So definitely Python fits very well within our
that's awesome.
Absolutely. Yeah.
So it sounds like your business, Whereabouts, is a little bit following the open core model, would you say?
Yes.
Let's round out our conversation here with talking about the business itself. How do you get the startup row?
We follow the open core model. You're totally right about that. So we have an open source software, Apache Sedona. It's available for free open source, very permissive license, the Apache license 2.0. And it's the open source. It's also used in operational production in so many use cases. There are so many contributors outside. I'm the original creator of it, as well as my partner Gia. We're both the original creators, but it's grew beyond us now. So there are like dozens, like 100 contributors now, something like this. And we use Sedona as an open core, but we build the whole platform around it. So if you want to think about like what we do compared to the other data platforms in the market, there are generic data platforms like Snowflake, Databricks. There are more specific, specialized data platforms like MongoDB for NoSQL. There's Neo4j for Graph. Whereabouts is like the data platform for geospatial. So this is basically, and we use Apache Sedona as an open core to enable us to do all of this. Yeah.
Fantastic. All right. Well, congratulations on being here.
Yeah.
I wish you success with the whole project, and thanks for coming on the show.
Thank you so much. I appreciate it. Looking forward to it.
Yeah. You bet.
Thank you so much.
Yeah. Bye.
Time to talk to Neptime, who have created Python programmable spreadsheets that are super powered with Python and AI. I gotta tell you, this product looks super awesome. It looks so much better than things like Google Sheets or Excel, and I can't wait to get a chance to play with it.
Hey guys.
Hello.
Welcome to Talk Python with me.
Yeah.
It's great to have you here. First, introduce yourselves.
Thanks for having us. I'm Dawa. I've been doing Python professionally for, 20 years or so.
Mm-hmm.
I'm Jack. I'm Dow's co-founder. Been doing Python a little less than that, but met Dow about 5 years ago, and we founded Neptime about a year ago.
Yeah. So, let's dive into it. Neptime, what's the product? What's the problem you're solving?
Yeah, the proposition that we have is pretty straightforward. We build a spreadsheet on top of a Jupyter notebook engine, which basically gives you all the data science superpowers that the notebook gives you in a familiar spreadsheet environment, which means that you can share your work as a Python programmer much easier with people that are not familiar with notebooks because they have the universal data canvas of a spreadsheet.
How interesting, because one of the big challenges data scientists often have is they work in Jupyter, and then some executive wants to share it at a presentation, or they want to continue working on it, but they're not developers. So what do? You write a Excel file and you hand that off, and then you re-import it somewhere, maybe? I don't know.
Yeah. The typical flow is indeed very much like you write out the CSV, you email that to the person that is going to put it into Excel. That person then creates a graph in Excel, screenshot that graph in Excel, and sends it to the person that puts it in the presentation, and then the CEO can do something with it.
It goes either in PowerPoint or it goes in Word. Yeah, one of those two, right? Probably the picture. But that's a bunch of steps that are disassociated from data. So that's one problem, right? That's the one problem. But since no one really sees your product in action while we're talking here, maybe just a bit of an explanation. Like it looks very much like Google Docs or one of the online Excel, I mean sheets, like one of the online spreadsheet things. It doesn't look like something embedded into notebooks, right?
Yeah, that's right. It is a spreadsheet first and foremost. It looks a lot like Google Sheets, but you can run Python in it.
Yes.
You can run Python both directly in the spreadsheet cells. You can also define other functionality in Python and then run that with your spreadsheet.
Yeah, I mean, to me, that's where the magic is, right? Like Excel or Sheets, the spreadsheets more broadly are super useful, but it's always like, how do I do an if statement in this dreaded thing again? And how do I do a max with a just all the programming aspect of going beyond just having raw data is just like, oh boy, this is. And you just showed me an example where, like, here you just write range of a thing, and boom, it just writes that out. Or you write a Python tertiary statement, and it just runs.
Right. Yeah, but also common things in spreadsheet that are hard are data cleaning, right? You get some data from somewhere, and it's not quite right. And most of the time, people end up doing this by hand. And that's fine the first time you do it. The second time and the third time, it gets very annoying. While if you just write a little bit of Python, you can clean data like that.
Yeah.
And then the next time you have the data, you just rerun the script and it's clean again. So that's a very powerful way of doing this thing. And we have a full Python environment. It's not just a lightweight, runs in the browser. No, you can do pip install anything you want. So you can connect to any API out there, use any data, export any data. It's a complete environment.
How interesting. Yeah. There's a little window where you can write straight Python, some function that does arbitrary Python, and then you can invoke it like a function in the spreadsheet, right?
Exactly.
And you can talk to things on the internet. For example, I could do web scraping or call an API, like a currency API.
Yeah, exactly.
Okay.
That's any REST call you want to make, you just import requests and go for it.
Wow. So where's it run? Is this a PyScript, Pyodide? Is this Sculpt? Is this Docker on a server?
It's all running in a Docker container,
okay,
server side. That's how it works. And that's kind of, we do that for maximum flexibility, maximum capability. So it means that anything you can install, anything you can run on a Jupyter notebook running on Linux, you can run in Neptime.
I see. So we get full Python 3.11 or 3.10 or whatever it is.
Yep. And we ship with a bunch of useful packages pre-installed. But if you want to install something else, you just open up our dependency management window, install anything else you want to use. It's all very manageable, very, very configurable.
Well, it looks super good to me. What's the user model? Do I go and create an account on your site and it's kind of like Google Docs, or what's the story?
Yep, exactly. You can try it out. You can go to neptime.com. In the upper right, just click login. You can create an account. It's totally free to use, the free tier. Yeah, give it a shot.
Awesome.
try it out.
All right, final question. How'd you guys get here in Startup Row? Everyone wants to build something amazing with open source, but how did you turn that into a business and something you can put your full time into?
I mean, I guess we're kind of lucky in that when we started, I pitched it to a bunch of people that, due to no fault of their own, got into some money, and they were willing to back us. And then later we joined YC for the winter batch.
Awesome.
And in that process, we, got a little bit of publicity and were picked up for the Startup Row.
Just to add to that too, based on our experience in Y Combinator, there are lots of open source tools out there that are able to get started on some commercial path just based on the community that they're building, based on the users.
Right.
It's a very good path.
I feel like this whole open core business model has really taken off in the last couple of years, where it used to be a PayPal donate button, and now it's a legitimate offering that businesses will buy, and it's good. I think it's very positive. So I'm really impressed with what you guys built. I think it's awesome. I think people will really like it. Yeah. So good luck. Thanks for being here.
Thank you so much.
Now up is Nixla. We have Federico Garza and Christian Chula here to tell us about their time series startup ready to make predictions based on an open source time series ecosystem.
Hey there.
Hello.
Welcome to Talk Python.
Hello.
Hello. Let's start with introductions. Who are y'all?
So I am Christian Chaliu. I'm a co-founder of Nixla.
Yep.
Hello, I'm Fede. I'm CTO and co-founder of Nixla.
Nice to meet you both. Welcome to the show. Really great to have you here at PyCon. And yeah, let's start with the problem you all are trying to solve.
Okay, yeah. So at Nixla, what we do is time series forecasting.
Mm-hmm.
So as you know, time series forecasting is a very relevant task that a lot of companies and practitioners need to solve. Mm-hmm. So essentially, predicting future values of something, right? It could be demand of a product or the weather. So there are many use cases for forecasting. It's a very common problem in industry. And essentially, we want to provide tools to developers, engineers, researchers to be able to do this more efficiently and with good practices. And yeah, that's mostly it.
Right. Okay. So is this like a Python API? Is this a database? Like what is the actual
That's how it looks
thing?
like.
Yeah, the product, I guess.
Product.
Yeah.
So we have an ecosystem of Python libraries, and we have different libraries for different use cases. For example, we have the stats forecast library, which specializes in statistical econometric models, and also we have more complex models and libraries for deep learning and machine learning applications. Yeah.
Nice. And have you trained some of these models yourself on certain data and things like that, or where do you get the models from?
The idea behind the libraries is that you can use whatever your data is. The only restriction is that it must be time series data, but you can use whatever data you have. Yeah.
Okay. Fantastic. And it's data. Python's at the heart of so much data processing these days. And I guess I give a shout out to all the different Python packages that are already out there. Maybe you want to just give a rundown on those and what they're for, and then talk about them.
Yeah, so we have like 6 packages right now. They are all libraries on GitHub that you can pip install or install it with Conda. And essentially, they focus on different ways of approaching forecasting. And they're essentially libraries built on Python. Depending, some are built on Numba. Other methods are in
you guys are using Numba?
Yeah.
Oh, okay. Yeah. And it makes a huge difference?
Yeah, it makes a lot.
All right.
Yeah.
Tell people really, really quickly, what is Numba?
So Numba is this library which allows you to compile just in time your code. So it's a lot faster than using just plain Python.
And how easy is it to use?
It's really easy.
Okay.
Yeah. In fact, we wanted to make our library more efficient and more faster, and we did it in like 2 weeks only using Numba. So it was really easy to use.
Yeah, awesome.
And some other packages use PyTorch. So like our deep learning methods, neural forecasting approaches are built on PyTorch or PyTorch Lightning.
Yeah, fantastic. So would you say that your business model is something of an open core model where it's kind of built on top of these libraries? And
Absolutely, yeah. So for now, we have been focusing on building these libraries, the community. We have a very active community on Slack and people that use us and contribute with our code. And we are building services on top of these libraries, like enterprise solutions or hosting computation, or even simplifying the usage further. So for example, APIs where you can just simply pass your data. I want to know what is going to happen next on this data.
Do you pass it some historical data and ask it to make predictions?
Makes predictions, and then we produce the predictions.
Okay.
Yeah, this is one of types. So we are working on these different applications and services.
Awesome. It sounds really cool.
Thanks.
So final question, how'd you make your way over here to Startup Row at PyCon? Like how'd you start your company and how'd you get here?
Yeah, it has been a long journey, long story. I mean, we have been for a year working on these libraries and services. And right now we are focusing on building the startup, right? We want to be able to do this full time for a long time and really, build something that can help people. Yeah.
Are you looking to offer an API, like an open AI sort of model, or running people's code as a service, or where are you thinking you're going?
Yeah, that's definitely one of the options. But yeah, we are finishing our funding runs. And once we finish that,
funding helps a lot on software development.
Funding helps a lot on development,
Sure
so we're exploring different venues, and there's very exciting things to come.
All right. Well, we all wish you the best of luck on your project, and thanks for taking the time to talk to us.
No, thank you for inviting.
Yeah, you bet.
Thanks.
Bye.
Bye.
We'll speak with Piero Molina from Predibase. They empower you to rapidly build, iterate, and deploy ML models with their declarative machine learning platform.
Piero, welcome to Talk Python to me.
Thank you very much for having me.
Yeah, it's fantastic to have you here. Quick introduction for everyone.
Sure. So I'm Piero and I'm the CEO of Predibase. I can tell you about Predibase in a second. I'm also the author of Ludwig, which is an open source Python package for training machine learning models. And
Awesome. Well, great to meet you. Tell us about your company.
Yeah, so Predibase.
Problem solving, yeah.
Yeah, so Predibase tries to solve the problem of the inefficiency in the development process of machine learning projects. Usually they take anywhere from 6 months to a year or even more, depending on the organizations, their degree of expertise in developing machine learning projects. And so with using our platform, companies can get down to from months to days of development, and that makes them substantially faster. Each machine learning project becomes cheaper, and organizations and teams can do many more machine learning projects.
Yeah, I mean, training is where the time and the money is spent. Yeah, at least to computationally. I mean, paying developers is expensive too. But in terms of, people say machine learning or AI, it takes all this energy, and it does take energy to answer questions, but it really takes energy to train the models, right?
Yeah, definitely. Training the models is a huge part. Managing the data and putting it in a shape and form that is useful for training the models is also another big piece of the reason why these teams take so long to develop models. And also, usually there's several people involved in the process. There are different stakeholders. Some of them are more machine learning oriented, some of them are more engineers, some of them may be analysts or product developers that need to use the models downstream. And so the handoff of the artifacts and of the whole process between these different people is also source of a lot of friction. And with the platform that we are building, we are trying also to reduce the friction as much as possible.
Yeah, it sounds great. Is it about managing that workflow, or is it about things like transfer learning and other more theoretical ideas? Like, where exactly are you doing this?
So to give you like a little bit more of a picture, I would say where we are starting from is from Ludwig, which is this open source project. And what Ludwig allows people to do, it allows to define machine learning models and pipelines in terms of a configuration file. So you don't need to write the low-level PyTorch or TensorFlow code. You can just write a configuration that maps with the schema of your data.
Okay.
And that's literally all you need to get started. So it makes it substantially easier and faster to get started training models. Then, if you're more experienced, you can go down and change more than 700 parameters that are there and change all the details of training, of the models themselves, the pre-processing, so you have full flexibility and control. And you can also go all the way down to the Python code, add your own classes, register them from the decorator, and they become available in the configuration.
Very cool.
This is what we have in the open source.
Right.
And what we're building on top of it is all the, again, you can think about this, like for people who may be familiar with Terraform, for instance, what Terraform does for infrastructure, so defining your infrastructure through like a configuration file, Ludwig does it for machine learning. Really. That's a good analogy.
Okay.
And so Predibase, what does it? It uses this basic concept of models as configuration, really, and builds on top of it all sorts of infrastructure that is needed for organizations that are big enterprises to use it in the cloud. So we have, we can deploy on cloud environments. We abstract away the infrastructure aspect of it, so you can run the training of your models and inference on either one small CPU machines or 1,000 large GPU machines, and you don't need to think about it, basically.
Oh, cool. So I just say train it, and if you happen to have GPUs available, you might use them?
Right, absolutely. Yeah.
Okay, excellent. So where does Predibase fit into this? Like, where's the business side of this product?
Right. I would say Predibase makes it easy for teams, really, to develop machine learning projects, right? As if Ludwig, you can define your own configurations, but it's like, let's say, single user experience if you want, right? Predibase becomes like a multi-user experience where, again, you deploy on the cloud and you can connect with data sources. In Ludwig, you provide like a CSV file or a data frame, a pandas data frame. With Predibase, you can connect to Snowflake, to Databricks, to MySQL databases, to S3 buckets, and do all of those things. And also, there's a notion of model repositories, because when you start to train a model, the first one is never the last one that you train. And so, an analogy to Git, really. In Git, you have commits and you have teams doing different commits and collaborating together. In our platform, you have multiple models that are configurations and multiple people training new different models spawning from the previous one. So there's all a lineage of models that can be compared among each other.
Yeah.
And then the very last piece is that we make it easy to deploy these models with one click of a button. So you go from the data to the deployed model very, very quickly.
Fantastic. It sounds great. So final question. A lot of people out there working on open source, they'd love to be here on Startup Row talking about their startup based on their project. It sounds like what you built is based on the open core model, which seems to be really, really successful these days. Tell us a bit about how you got here.
Right. So basically, I think it started from the open source, really. I started developing Ludwig when I was working at Uber. And initially was like my own project, was a way for myself for being more efficient and working on the next machine learning project without reinventing the wheel every single time. And I built that because I'm lazy and I don't want, when I do one thing more than twice, then I automate it for myself, really. That's
productive laziness or something like this.
Yeah. And so then other people in the company started using it. And that convinced me that making it open source, also because it was built on top of other open source projects, would have been a great way to both have people contribute to it and improve it, and also to give back to the community because, again, I was using myself a lot of open source projects to build it, right? And then from there, I made it so that we donated the project to the Linux Foundation. So now it's backed by the Linux Foundation. And also the governance is open, as opposed to what it was before when I was at Uber. And from there, actually, I met a bunch of people, some of my co-founders at the company, thanks to the project. And we decided that, so for instance, one of them is Professor Chris from Stanford. He was developing a similar system that was closed internally at Apple. And so we said, this thing worked at Uber, worked at Apple, works in the open source. Let's make a company out of this, right?
Fantastic. Yeah, solving some problems for these big teams, right? Excellent. Well, best of luck on your company.
Thank you very much, Mike.
Yeah, thanks for being here.
Yeah, absolutely a pleasure.
Yeah,
Thank you so much.
We'll finish up our stroll down Startup Lane by talking with the folks at PyCon. We have Nikhil Rao to talk about the pure Python full stack web app platform that they've built.
Nikhil, welcome to Talk Python.
Yeah, great to be here. Thanks for having me.
It's great to have you here. I love going through all the different projects on Startup Row and talking about them and shedding a little light on them. So happy to have you here. Yeah. Give a quick introduction on yourself.
Yeah, so I'm Nikhil. I'm the CEO, co-founder of PyCon, and we're building a way to make web apps in pure Python. So we have an open source framework, and anyone can install this and basically start creating their apps, front end and back end, using Python. Our company went through the recent Y Combinator batch, just ended the Winter 23 batch. And recently we raised our seed round and starting to hire out and pretty much grow out our project and company from here.
Okay, well, awesome. Congratulations. That sounds really cool. Give us an idea of, I guess, why do you build this, right? We've got Flask, we've got Django.
Yeah.
I mean, heck, we even have Ruby if you really want it.
Yeah. There's a lot. So previous to this, like you mentioned, there's frameworks like Flask and Django. And whenever a Python developer wanted to make a web app, they use something like this, but you always have to pair it with another front-end library. So you can't just make your front end using Python. You still have to end up using JavaScript, HTML, React, stuff like that for your front end. And so a lot of people, if you're coming from a Python background, it's a lot of work to kind of get started with these. It's a different language, different tool set. So we really wanted something where Python developers can just use the tools they already know and be able to make these web apps without having to go learn something completely different. So as opposed to these tools like Flask and Django, we're very focused on unifying the front end and back end into one framework. So you don't need a separate front end and back end. And that allows us to the user can just focus on the logic of their app and not kind of these technical details on the networking and all this other stuff.
Yeah, it sounds interesting. I mean, I know many Python people who don't want to do JavaScript.
Yeah.
They don't want to do multiple languages.
Exactly.
But, it's traditionally, at least in the web framework world, you're speaking many languages. You're speaking HTML, CSS, JavaScript is a big one. And honestly, I think there was a period where people were super invested in JavaScript and thought that was kind of the right way or the necessary way. And that would take away a lot of, what's important about the web framework, right? Like, it doesn't matter if it's Flask or Django. We're just going to return JSON anyway because it's all Angular, so who cares, right?
Yeah.
But I don't think that's where people many people, at least the people choosing Python, want to be. And so, how is your stuff different?
So I think exactly what you said before this, to make a serious web app, you always had to go to JavaScript. And what we're really trying to do is make everything in Python, including your front end. And so basically, we're trying to integrate the two together. So basically, you don't have to go learn these technical details you didn't want before. We realized for all the logic of your app, you're using Python anyway. Like Python's used in so many industries, databases, ML, AI, infrastructure. And when these people want to make a front end, it is possible to make JavaScript or these JavaScript front ends, but it's a lot of overhead. And before our framework, there are different low-code tools to make front ends without JavaScript, but they all kind of have a limit. And they all have a graduation risk, is what we found. So you can start making your UI.
Yeah.
But can you make any website with them?
Right. Like Streamlit and Anvil are both notable ones that kind of come to mind. But neither of them, I like them both a lot. But neither of them are necessarily, I'm just going to build a general purpose web app. They're focused in their particular area.
Yes, exactly. So I've used tools like Streamlit, Gradio in the past, and a lot of that was inspiration for Pinecone. It's really great because it's super easy to get started with. You don't have to go learn these things, but they all have this kind of ceiling you hit. So they're mostly good for data science apps, dashboard apps. But as you try to expand your app into a full stack web app, start adding these new features, a lot of times you find these frameworks don't really scale with your ideas. And your two options are either you have to kind of constrain your idea into what these vendors offer you, or you use that for prototyping, and when you're making a customer-facing production app, you scrap it and go to a JavaScript React world. So what we're really trying to do is make something like these Anvil or Streamlit easy to get started with for Python developers. But as you want to expand to these complex cases, you should be able to stay in our framework, and we should be able to handle that also.
Interesting. So how does the front-end interactivity work if it's Python?
Yeah, and this is also where I think we're a bit different. We're trying to really leverage a lot of the web dev ecosystem and not recreate everything from scratch. So for the front end, we leverage React and Next.js. So our front end compiles down to a Next.js app. And from this,
you're transpiling the Python?
We transpile the Python to Next.js, and this gives you a lot of great features. You get single-page app features from Next.js, a lot of these performance features, and that means from our perspective, we don't have to recreate all this stuff. And also, we don't have to create components one by one. We just leverage React, and for what we do in Pinecone for the front end is we just wrap React components and make them accessible. So even if we don't offer something, in other low-code tools, sometimes if they don't offer a component you need, you may be kind of constrained in what you can build. We easily have a way for anyone to wrap their own third-party React libraries. So we're really trying to make the existing stuff out there accessible rather than recreating it.
Yeah, so you can sort of extend it with React if you get boxed in. That's your escape hatch?
Exactly.
Okay.
So that's kind of how our front end works. And for the back end, we use Fast API to handle all the state. So the user state is all on the back end on the server. And this is what allows us to pretty much keep everything in Python. So none of the logic is transpiled to JavaScript, only the React. And all the logic stays in Python. So you can use any of your existing Python libraries, any existing tools. You don't have to wait for us to kind of make these integrations. So it's kind of leveraging React, but also leveraging Python and kind of bringing them together.
What's the deployment look like?
So we're working on an easy deployment. So you can just type PC deploy. We'll set up all your infrastructure, and you'll get a URL back with your app live. But also, we're an open source framework, so it's also very easy to self-host and self-deploy. And so what we're really trying to do is make it accessible and easy, but never kind of lock you into our framework.
I see. So I could put like Nginx in front of it or something.
Exactly. So right now we're still working on our hosting deployment. So everyone right now who's deployed is hosting on AWS DigitalOcean or a tool like this with Nginx. And so it integrates just like you would deploy a Flask or React app.
Got it.
But we're really trying to make an optimized hosting service around this later.
Yeah, sure. Makes sense. All right. Sounds like a great product.
Thanks.
Final question here. How'd you get here? How'd you start the company? How'd you land on Startup Row? I mean, you talked about Y Combinator a little.
Yeah, so I talked a little bit. We did the Y Combinator batch, and really the idea is not only having an open source framework, but having like a business model around it and being able to create like these features around it. So we're really focused on kind of being similar to have an open source framework, similar to like how Vercel has Next.js and their hosted version, and kind of bringing that to the Python community. So Python is like one of the fastest growing languages, obviously, like that's why PyCon is so big. But for the web dev part, there's not really a good ecosystem for that. So when people want to share their ideas, we're really trying to become that de facto way for Python developers to create their apps and share it. And so, yeah, basically working on our hosting servers, growing out our team now, and trying to build out all this like ecosystem around it so people can easily get their ideas out to the world.
Awesome. Well, congratulations and thanks for being here.
Thank you. Yeah, thanks so much.
Yeah, you bet.
Great being here.